Welcome you all to the video lecture of Introduction to Electrical and Electronics Engineering. Here in this video lecture, we are going to discuss about the topic related to the module 1, so mesh analysis and the nodal analysis. In our previous classroom session itself, we have discussed about what is meant by a mesh analysis and nodal analysis, which means that by using which Kirchhoff law it going to get involved in the mesh analysis and nodal analysis. All those things we have already discussed in our classroom. For a short note, the mesh analysis related with the Kirchhoff voltage law, and followingly the nodal analysis deals with the Kirchhoff current law. So with respect to this Kirchhoff current law and voltage law, we are going to form the equation and solve to the questions asked. So let's directly go for the problem. Here in this circuit, they have mentioned we need to find the mesh analysis for each branches. They have mentioned as for each branch we need to find the mesh current value. So first, after given the question, we need to find how many loops are there in the given problems. So here in this question we are having two loops. So loops means what? A closed circuit. Here this P, Q, S and this part. So it follows the closed loop, and followingly this Q, R and this point and S. So it is a closed circuit. So with respect to this loop, two loops we obtained from the equation. We obtained from the question. Now we are going to form the equation with respect to that of closed loop, which means that the closed circuit. So from the loop 1, P, Q, S and P, the loop 1 equation is going to be finding out. So here this 40 ohm resistor, so this 40 ohm resistor is now going to be changed over as a minus 40 I1. Why this I1 means? Here this I1 says is that the I1 current is flowing in this 40 ohm resistor. So the direction is from negative to positive. This voltage source is obtained from the negative to positive. So the opposite side of potential is going to get interacted over this resistor. So we are mentioning this as a minus. So minus 40 into current is the I1 current is flowing across this 40 ohm resistor. So followingly this 20 ohm. So this 20 ohm involves I1 and I2 current. So that only I have mentioned as I1 minus I2. So partial amount of I2 current is flowing here, so that it is indicated as in the negative part. So this minus 20 into I1 minus I2 plus. So here this 120 volt. So for the voltage source from negative to positive, we going to indicate with the positive sign. Followingly, from the positive to negative flow of voltage means we need to indicate in the negative sign. Here it is from the negative to positive. So I have mentioned as a plus 120. So after simplifying this, which means that this 40 minus 40 I1 and this minus 20 is going to be multiple over here this I1 and I2. So minus 20 I1 and plus 20 I2, and this plus 120 is taken over to the right hand side. So finally the equation number 1 says us about minus 60 I1 plus 20 I2 equal to minus 120. This is my equation number 1. So the second loop is what? Q, R and S and Q. This is the closed loop. So with respect to the same method followed in this equation number 1, we are going to find the equation for this Q, R, S and Q loop. So here this 60 ohm resistor have the I2 current, so I have indicated this I2. So the flow is from where? So minus to plus only. So the resistor initially the resistor have here the positive and the negative. So automatically we have going to mention here the sign as a minus 60 I2, and followingly the current flow is from plus to minus. So we need to mention as a minus. So here I have mentioned as a minus 50 voltage source. So here this 20 have what? The mixture of I2 and I1. We have already seen in this equation number 1. But here this I2 current flow is the major dependent current source in this 20 ohm. So this I2 is in the partial mode. So minus 20 I2 minus I1 I have mentioned as a I2 minus I1. Here we have mentioned as I1 minus I2. So but here this I2 is going to be get involved more than I1. So the equation number, finally the equation 2 get consolidated as a minus 80 I2, which means that this 20 is multiple over here this. So automatically 60 minus 20, so minus 80 I2 plus 20 I1 equal to 50, equation number 2. Okay, here we have get the equations 1 and 2. So by using calculator we are going to get find this I1 and I2 value. We have already discussed regarding to that of calculator method of finding the equations. So just go for the equation part. Here the unknowns are two unknowns, I1 and I2. So selected two unknowns and mention the values minus 60, 20 and the constant value is minus 120 and followingly so 8 which means that A1, B1 and constant C1. Here this minus 80 get applied over in A2, B2 and C2 in the calculator. So and then we got the value as x and y. So this x and y we are mentioning as a I1 and I2. So in calculator we get minus plus 1.9545 amps current for I1, and for I2 we get as minus 0.1363 amps. So in calculator we got in the position of x and y. So the x deals is with the I1 and y deals is with the I2. So, okay. So here in this question we need to find the current in each branch. So here this I1 and I2 follows the branch of 1 and 2, and another branch is there. This Q and S is the another branch. So this Q and S is the it has the flow of both what I1 and I2. So I automatically going to get add this I1 I2 values only, not their signs, since because the I2 has the value as a minus 0.1363, but doesn't here we doesn't need to get consider over the signs involved in the branch 1 and branch 2 current. So automatically just add the values, numerical values 1.9545 plus 0.1363. So automatically the branch 3 current has a 2.0908 amps. So from this question we have find the answer for the branch 1, branch 2 and branch 3 current.